So we're going to look at the quiz from October 25th in Strength of Materials 1. So the question was, here's a beam or a bar, and here are the loadings on the bar. So solve for the force FD, assume loading is static. Okay, so that's a pretty simple or pretty straightforward, I should say, way to solve this. So basically I have an unknown force here. I have all these applied loads, and you know the sum of them must equal 0. So FD plus all these forces must equal 0. So just to go over to, so what we're saying is for the entire bar, since it's static, sigma f x equals 0. X is in this direction, and this direction is positive. Okay? So going back to our image here, we're going to have FA plus FB plus SC plus FD plus FE equals 0. So equals FA plus FB FC plus FD, and there is an E, right? Plus FE equals 0. And this is the one that's unknown. So now we're going to go back. By writing this plus here, okay, I've assumed that it's going to be in this positive x direction. Don't forget that, okay? So I've assumed that it's going to be in the positive x direction. So let's sub in. So FA is 10, 15, and negative 20 for FABC. So 10 kilonewtons plus 15 kilonewtons minus 20 kilonewtons plus FD. And then what is FE? Minus 20 equals 0. Okay, so 10 plus 15 is 25. Minus 20 is 5. Minus 20 is negative 15. So FD minus 15 kilonewtons equals 0. FD equals 15 kilonewtons. So that means there is a positive 15 kilonewton force right here that makes this entire bar static. Okay, the next question is solve for the internal forces in each section. Show all FBDs. Okay, so the first one's pretty easy. Almost everyone got it. We're just going to slice right here and then draw our free body diagram. Okay, so section, go back here, section AB. So this is going to be A. And now we're going to slice here. And we're going to have some unknown n, and then this is 10 kilonewtons. Well, that's pretty easy, right? So sigma f x equals 0 equals 10 minus n, or n equals 10 kilonewtons. Okay, so that means n in this section here is 10 kilonewtons. That would be a compressive force. Okay, so now we'll do the next easiest one. We're going to go over here. If you just slice right here, and you're essentially erasing all of this, and you're just looking over here at what's going on in this section. Okay, so let's go draw our free body diagram. Sorry, this was A, and now we're going to be looking at E, right? So we're going to have, let's just draw a line to keep this separate. Okay, so now we're going to do E, okay? And then we're going to have some unknown here, N, okay? And we're going to do the same thing, sigma fx equals 0. Sorry, what is, so E is going this way at 20 kilonewtons. Okay, so it equals n minus 20 kilonewtons equals 0, n equals 20. So that means there is a 20 kilonewton force in this direction, which means this section is in compression. And go back here, since they're going in the opposite directions, this section is going compression. So here is where the next step is where things start to break down for a lot of people. So if I take a slice right here, I'm going to look this way. So then I'm going to erase everything here. I'm just going to look at this. I'm going to have A, B, the load here, and some unknown N in here. I can't slice here and here, right? Like I can, you can do that, but you have to, it's more complicated and you have to start to look at internal forces, okay? What you do is you slice here, and then you just look all the way to the end of the bar this way. You look all the way to A, okay? So let me slice. Let me just do this here. So we're going to have this is A, B, and this is my slice. So I'm just going to assume got some kind of N there. And so this F is 10 kilonewtons. This F is 15 kilonewtons. Right? So sigma Fx equals 10 plus 15 minus N equals 0, or N equals 25 kilonewtons. Okay? So what that's saying is that reaction there has to, since we're in static, has to offset or counteract these two forces here. So the internal load here is 25 kilonewtons. Okay, and we get that through method of sections and free body diagrams. Let me scroll down. Okay. So now we're going to go look at A, B, C, and then we're going to slice. Actually, let's just slice right here. Okay, we know it's in BC. We slice right here, and then we look this way. Okay. So again, we're going to slice here and then look this way. So we're effectively erasing all of this. Okay. So here we go. So we're going to have D, you're going to have E. All right, so E is 20 this way. I'm going to have FD. We solve for FD. What was FD? FD was 15 kilonewtons, okay? So it's 15 kilonewtons this way. Okay? And then we're going to have some unknown. I'm just going to assume it's in a positive direction. So we just sigma Fx equals 0 equals N plus 15 kilonewtons minus 20 kilonewtons equals 0. Therefore, N equals 15 minus 20 is negative 5. Bring it over, goes to 5 kilonewtons. So this internal force here is equal to N. Now, what if we go the other way, right? We sort of have to get the same answer, right? If it is in static equilibrium. Okay, so we're going to do one last case where instead of going DE, slicing here and looking at that, we're going to go this way. We're going to do the slice in the same section, but we're going to look this way. So we're going to have A, B, C, and then some unknown N. Okay? So here we go. All right, that's A, B, C, and I'm just going to assume a positive N. Okay, so A was 10. This is 15. And what was C? Negative 20. Okay, so sigma Fx equals 0 equals 10 plus 15 minus 20 plus N equals 0. And 25 minus 20 is 5. So N equals negative 5. Okay, so that's saying the N is in the other direction. And if you think about it, that totally makes sense, right? Because when you look at it this way, the force has to be this way, but when you take your free body diagram the other way, it has to be the opposite. So it has to be pulling this way. So this confirms that we're going to get the same answer by looking at it either way. Okay, this force here, if you think about it from a free body diagram perspective, actually it's going this way. Well, that makes sense because the other force is going the other way. So by nature of free body diagrams, you know that when you slice and look this way, whatever your internal load is here, it has to be in the opposite sense when you slice the other way. Or you'd have movement, okay? So that is how you solve today's quiz. Be sure to send me an email if you have any questions.